introduction of arrays, we've introduced two new terms for programming in general. An array is a collection. This simply means a group of primitives or objects of the same type. Now, an array is known as a list type of collection. A list is essentially a group of items or objects that are in some sort of order, one thing before the other. Now that we are familiar with lists, we can start doing more complex tasks. Two of the more complex tasks that we like to do with lists are searching and sorting. This video is going to cover searching. The two different algorithms we're going to be covering is a linear search and a binary search. Linear searching is literally searching in a line. You start at one end and you search in order till you find what you're looking for. In an array, you can start from either end. For example, I want to locate 15. I'm going to start at index 0 and then make my way across. One other term that we're going to talk about is iteration. An iteration essentially means one time that I do a specific set of operations. It could be one operation or many operations. So in this case, I'm going to repeat the same operation over and over again. Each time I repeat it, that is called an iteration. So let's see how many iterations it takes me in a linear search to find 15. I'm going to start with index 0. Does 22 match 15? Nope. I'll go on to the next one. Does 19 match 15? Nope. I'll go to the next one. Does 41 match 15? No. Does 30 match 15? No. Does 15 match it? Yes, it does. So how many iterations did that take me to find 15? It took me 1, 2, 3, 4, 5 iterations. Now, assume I want to find 25. 25 doesn't exist in the list. How many iterations will it take me to find 25 in that list? Let's find out. It'll take me 1, 2, 3, 4, 5, 6, 7, 8, 9. It took me 9 iterations to find out that 25 does not exist in my list. Now, let's assume this list is 1 million items long. If the list doesn't have the value I was looking for, I'd have to loop and iterate 1 million times to find out that it wasn't in the list. That is very inefficient. What if I knew that my list was already in order, which is called sorted? Is there some way of searching my list to find if an element exists? Binary searching gives us a more efficient way of searching through a list. If I know something about my array, that the values are sorted in some sort of order, I can take what I know about the list and split it in half. If I search the middle item and discover that it is bigger or smaller than what I'm looking for, then I can search the next portion of that list, the upper or lower portion of the list. So let's search for the number 22. You can see that the numbers are all sorted in ascending order. I'm going to take the midpoint of that. I'm going to keep track of 3 different values. I'm going to keep track of the lowest portion of my search area, the highest portion of my search area, and the midpoint of that search area. So in this case, I'm searching the entire array. My lowest point is index 0. My highest point is index 8. My midpoint is 4. I'm going to take the value at index 4, number 19. Is 19 match 22? No. Is 19 higher or lower than 22? It's lower than 22, so I know that I want to search this portion of the list. So I'm going to change a couple values. I'm going to change my low value. Instead of searching the entire list, I'm going to start with 5. I'm going to make my low 1 plus the midpoint. So my search area now becomes this portion of the list. I'm going to take my midpoint, which is 5 minus 8, which gives me 3, and I'm going to say 1/2 of 3 is actually 1 in integer math. So I'm going to add 1 plus the midpoint and find that my midpoint here in an even number array is actually 6. Alright, so midway of this next search area is 6. Since there's not really a midway point, you don't have 6.5 of an array. I'm going to say, is 30 higher or lower than 22? Since it's higher, I know that I want to search the lower portion. So I'm going to change my high point now to 5. So my low point and my high point is now 5, and my search area is this last piece. I'm going to search my midpoint of between hot 5 and 5, which is 5, and say, does this value equal 22? It does, and I've found my item. In this case, how many iterations did it take for me to find 22? Well, my first iteration is the first midpoint. The second iteration was finding this midpoint, and my last iteration found this midpoint. So I only took 3 iterations to find what I needed to find. Now in this array, finding any number will only take me 3 iterations. So let's try and find a number that doesn't exist. Let's try and find 21. Actually, let's try and find, let's say, 16. And we'll go through the same steps. My midpoint, my low is 0, my high is 8, my midpoint is 4. So this is my first iteration. Is 16 higher or lower? It's higher than 16, so I'm going to use this portion. My high is going to become 3. My low is still going to remain 0, and now my midpoint is going to become 1. I take a look at 12. Is 12 higher or lower than 16? I say that it's lower, so now I know that my search area is going to be above the midpoint. So my new low is now index 2. My high remains 3, and my midpoint is going to become 2. So this is my second iteration. So is 15 higher or lower than 16? I see that it's lower, so I'm going to raise my low point up to 3. Now I'm going to search 3. My low is 3, my high is 3, my midpoint is now 3. Does 19 equal 16? This is my third iteration. 19 equals 16? No, it doesn't. Is it higher or lower? It's lower, so we're going to, that's our third iteration, we're going to set our high point down 1. Now, we've hit a point now where the low is higher than the high. At this point, we know that the item does not exist in the list. So we've essentially done we've done 4 iterations. Our fourth iteration, the first one, our second one, our third one, and then our fourth one. Our fifth time, we've noticed that high is lower than low, and it doesn't exist in the list. The last thing I wanted to point out is about the efficiency of searching. If you've noticed that in most cases a binary search is more efficient than a linear search. If I wanted to find 30, it would take me 1, 2, 3. If I wanted to find 30, it would take me 1, 2, 3, 4, 5, 6, 7 iterations to find 30. If I wanted to find 30 using binary, it would take me 1, 2 iterations. So I'd split it in half, find this my midpoint, find it right there. It would take take me two chances to find it. Also, if the item doesn't exist in the list, like say 23, well, what we did earlier, it would take me 9 iterations. And if I was to try to find 21, which doesn't exist in the list, it would take me 1, 2, 3 iterations to find that 21 doesn't exist in my list. Now, there is one scenario where a linear search is more efficient than a binary search. And that would be is if the value that we're searching for exists and it's earlier on in our search. Let's say, for example, 12. If I wanted to search for 12 using a linear search, it would take me 1, 2 iterations. However, if I wanted to do a binary search, it would take me 1, 2, 3 iterations if I wanted to find 12. Because I'd have to split it, I'd have to find it in half, split it again, and then I would find it. So notice, and not in all cases, that a linear search is only in a few cases is a linear search more efficient than a binary search. Lastly, I wanted to point out is that you cannot do a binary search if the list is out of order. Back to that thing we had before, if it's 19, 32, 21. At this point, I can only do a linear search. A linear search doesn't care about the intrinsic values that are in the list. It only cares about searching one at a time. You cannot do a binary search if the values in the array are out of order. Let's review what we've covered up till now. A collection is a group of primitives or objects. An array is a collection called a list. Objects in a list are necessarily ordered one after the other. They don't necessarily need to be sorted, but they need to be in order 0, 1, 2, 3, 4, 5. A linear search is searching a list from one end to the other. You can start at the beginning, 0, 1, 2, 3, 4, 5, or you can start at the end of the list and work your way back to 0. A binary search is when you split up a sorted list into higher and lower sections. You search the middle and you repeat using either the higher or the lower section until you find the value, or it's not logically possible and it's not in the list. A binary search is faster than a linear search unless what you want appears earlier on in the list. And finally, you can only perform a binary search if the list is already sorted. You can perform a linear search if it's not sorted, but you cannot perform a binary search if the list is unsorted.